Hello, my name is Helsel. I'm in 7th grade and I attend infantry prep school. And the title of my project is Speakers. There are a few people I'd like to acknowledge before I start my project. The first person I'd like to acknowledge is my mother, Anne, for helping me throughout the year on my science fair. Another person I'd like to thank is my father, David, for guiding me with everything I need to do this project. Another person I'd like to thank are my siblings for giving me ideas on what to do on the science fair. The final person I'd like to thank is my science teacher, Ms. Nancy Mosher, for helping me throughout the year and over the summer on the science fair. The purpose of my project is to see what is the effective water temperature on how long it takes to freeze. I did this because I love ice and it always seems to take so long to freeze. My hypothesis is that if I use hot water, then it will freeze faster and cold. I think this because of the chemical effect. Chemistry can help to predict how long it will take water to freeze. Many have tried to explain this, but failed. There are many theories surrounding the chemical effect, including evaporation and insulation. Many people think there is no solution, but there is. There has been a solution since Aristotle first noticed it in 350 BC. One of the main reasons hot water freezes faster than cold is because cold water forms an insulation layer of frost very fast when you put it into the freezer. Hot water also evaporates off some of its water instantly when you put it in the freezer, leaving less water behind, making it take less time. Some people disagree and get different answers. There are many reasons behind this. Some are because our water may have more, less, or different impurities. They may also use different types of water, have a different method of freezing, or a different type of container, and they might also have a different type of freezer.
There will be a sponsors meeting in section 209 in about 2 minutes. Sponsors meeting, section 209.
First, to discuss this, it is necessary to know what something needs to freeze. For something to freeze, it must be in an environment of 0 degrees Celsius or lower. This is because an extremely cold environment brings down the temperature of the water until it contracts into a solid, which is ice. It is also necessary to know what freezing is. Freezing is a change in the state of water which occurs at 0 degrees Celsius as the water slowly contracts into ice. Many people have noticed that hot water freezes faster than cold. One of the first scientists being Erasmus Mapimbo. He first noticed it in college when he was making ice cream with his friends and he used hot water instead of cold water. His ice cream finished much faster than his friends, and that's when he noticed the Mapimbo effect. He then went on to state the Mapimbo effect, which states hot water is the fastest way to freeze water. The Mapimbo effect can easily be explained. One way to explain it is that boiling or hot water easily evaporates off some of its water, which makes it take much less time, while cold water does not. It is not the main reason, but it helps. Another thing that helps is water density. Cold water is much more dense than hot water, which makes it sink to the bottom, causing convection currents. Convection currents lower the rate of cooling and make it take much longer to freeze. Not only does cold water have convection currents, but it also forms a layer of frost. This layer of frost insulates it and drastically lowers the rate of cooling. This makes it take much longer, while the hot water does not form a layer of insulation, otherwise known as frost, very late into the testing. You can also explain the Mapimbo effect with water conduction. Conduction is when the material the water is in touches a cold surface. The coldness transfers to the water and makes it cool off much faster. This is why some scientists get different results. The reason they get different results from this is because some use metal containers while some use wood or plastic containers. Wood or plastic containers are bad conductors, while metal containers are very good. The Mapimbo effect can also deal with radiation. Hot water radiates much more than cold water. Radiation is when the hot water releases some of its energy, making it cool down very quickly. Cold water does not release much of its energy, so it takes much longer to freeze. Slow freezing can also explain why some scientists get different answers. Some scientists freeze their water, it may be moving, which makes it take a very long time to freeze, or will make it so it does not freeze at all. So, if a scientist is freezing water and it is not moving, it will freeze much faster than a scientist who does have the water moving. Another thing that causes hot water to freeze much faster than cold is the impurities. When water is heated up, it releases some of its impurities, like oxygen, the oxygen lowers the rate. The oxygen lowers the freezing point, which makes it take much longer. So, since cold water does not release any of its oxygen, it takes much longer to freeze than hot. There are many examples of this in everyday life. One example is on a cold winter day. If you go outside with hot or boiling water and throw it in the air, you can instantly see some of it evaporate and ice pellets fall to the floor. You can also explain the chemical effect with air convection. Air convection is the reason some scientists get a different answer than others. A scientist that has a freezer with fans will get different results than a scientist that has a freezer without. This is because the flow of air in a freezer makes the water freeze much faster. An example of this is that on a windy winter day, water outside will freeze much faster versus a warmless winter day. In conclusion, you might sometimes need ice, but not air. In this case, you will need to use hot water because hot water freezes much faster than cold. This is due to installation of evaporation of materials. My procedure is that first I have to gather the water at my preferred temperature from the faucet. Next, I put my water into my container and put the container into the freezer. After that, I start my timer and check on my water periodically. Once the water is frozen, I write down the data and repeat my procedure 10 times for each temperature. After all my temperatures are done, I record my data, which you will hear. Room temperature performed at an average of 3 hours and 25 minutes, which was 15% better than the worst, which was boiling, but took 15 more minutes than hot, which was the best. Hot performed at 3 hours and 10 minutes, which was the best. Boiling was the worst at 3 hours and 50 minutes on average. My data shows that I was both precise and accurate. My standard deviation was only 4 minutes, which was not a significant difference, so I was very precise. In conclusion, my scientific question was, what is the effect on water temperature on how long it takes to freeze? My hypothesis was, if I use hot water, then it will freeze faster than cold. This also means that hot water is the fastest way to freeze water. Some of the main reasons are because hot water does not form a frost layer very early in the testing, and it has a much higher rate of cooling than cold. Cold performed at 3 hours and 40 minutes because it quickly formed a layer of frost insulating it. Boiling performed at an average of 3 hours and 50 minutes because the extremely high temperature defrosted my fridge and made it warm. The fridge had to get cold again before it could freeze. The temperature performed at 3 hours and 25 minutes on average because it formed a layer of frost late in the testing, but not as late as hot. That is fact.
So, Sam? Very good. Very nice. Oh.
All the way through.